Our product examination is on an Asus G01KB computer keyboard. This keyboard is a mass-produced membrane switch keyboard. The main components are screws, an outer shell, a keyboard matrix circuit, membrane switches, 3mm flangeless LEDs, encoder, keycaps, knob cap, a USB cable, and a USB connector.
Below are the three main manufacturing processes throughout the keyboard. They are machining, plastic injection molding, and laser printing. The screws hold a majority of the keyboard components together, and we assume that they are made of steel. We believe that the manufacturing process used to create the threads is thread rolling. An alternative method would be thread cutting.
The outer shell of the keyboard is manufactured using plastic injection molding. This is because it is efficient for large-scale manufacturing plastic components. Alternative methods are 3D printing and CNC plastic machining. The keyboard matrix circuit and membrane switches are manufactured using laser printing. Alternative methods for this would be hand soldering.
As for the 3mm flangeless LED light, the manufacturing process involved molding a clear plastic around the electrical components. An alternative process will be involving resin casting or using epoxy. For the encoder sensor, metal is likely drawn due to thin dimension requirement to bend over the circuit. To create the cylindrical profile on the encoder head, it is likely machined using a mill or CNC machine. As for the alternative process, the thin metal sheets could have been done by using subtractive process on the sheet metal or by die casting, which could lead to surface defects.
The plastic keycaps and knob cap are likely injection molded from ABS. You could tell from these gate marks left by the connecting runners. Alternatively, they could have been 3D printed, though you might run into some reliability and surface finish issues. Alternatively, they could be also plastic machined, though that might be wasteful for mass production. The USB cable is made from many small wires, which are first drawn and then woven together for strength. This is then coated in thick insulation material. Alternatively, this could have been done with heat shrink, though heat shrink is a lot thinner than the current insulation. For the wire itself, it could have been done with a single large diameter wire, that this would be a lot weaker than the woven wire.
For the USB connector, the processes involve art drawing, which is a metal process that involves force and pressure to shape the material. Also, it has soldering and injection molding. Some alternative processes that we thought of is subtractive manufacturing. However, this won't be efficient due to specs and part complexity. And this is a disassembled time-lapse video that I recorded with my phone to show the whole process. And these are references. Thank you.